Let's try make one test to show the difference between the clamping system between two saw frames. The classic one, German, maybe is majority of the jewelry in the world was this one, and this made by me in titanium. So what's the idea? When you put one saw between these two parts here, we are calling these jaws, the blade must stay in the place, because if the blade slips or if the blade release, they can break and destroy your work or not work efficient. So this German system, you have the frame itself, and you have another metal part which go on here, and the blade go in between, and you need to press. So to press, you use one screw, and to make smoother the movement, have one washer. So this washer is to avoid when this part here of the screw touches the jaw, it gets stuck. So when you turn, the washer turns and minimize the friction and increase the power. So this is very smart and simple solution. But one of the problems here we can improve is this jaws here is soft. So when the blade is squeezed here, the blade with the time start digging one groove here and clean all these small serrations and grooves have here to improve the grip of the blade. So with the time you need more strength, more power, and when you start using, after a while, just the strength of your hand is not enough, so you need to take some plier and tight this, so it's a little bit frustrating. So to try improve this in this titanium frame, the solution was coating the titanium. Titanium also soft, but coating with tungsten carbide. Some place they call this Vidya. But this tungsten carbide is harder than the blade. You see this scribe here is very hard, but just slipping in the surface. So the blade cannot dig holes and destroy the surface here because this is harder than the blade. And to improve the clamping force, I add one more washer, and this material here is like self-lubricant. You can get more power, more strength. This is like one bearing. Mechanical we call axial bearing. It's like one bearing who's moving in this way in the axis. So here between these two jaws we put our blade, here the same, and in this case here we have this titanium screw with these two phosphor bronze washers like bearing. And one more interesting thing is this became magnetic, so sometimes also your frame can attract and keep the metal magnetic particles in the case you are soil, iron or something like that. And we use two blades, same manufacturer, same lot, same package, and we squeeze these screws with the same strength. So to make sure you use the same power, we will take help from this wrench here. In English name is torque wrench. So this basic one spring, we have all the family here. Have the small one, the normal, the smaller one. So just to make more clear, so when this wrench turns, we can set one force here. So when they reach this strength, they slips and click like this. So here we have two torque wrenches set to the same power, just to make a more visual reference here. Here we have 0. So when you reach around 110 here, the wrench backs to 0. But this is too light, see? Too light. If applied this strength, is not enough to squeeze the blade to stay in the place. So we need more power. So I found the normal average strength, the human hand. Of course, have some people have less strength and other ones have more, but the average. And if we measure it in 1 unit, centimeters Newton or centinewtons meter, don't mind, we can call carats or any name you want, but here have some numbers. So when your hand put this pressure, the average human power to squeeze this in centinewton meters is between 40 and 50. It's like half Newton meters. So just to have one idea, when you tight this M5 metric 5 millimeters thread with one wrench in some machines, it's about 3 times more, at least 3 times more when you use one wrench. But with the hand you don't have too much leverage. So this is between 0.2 to 0.5 Newton meters. So we use this in both frames, and let's see if have some difference. So let's first set the blade here in the German. We use this adapter here to so we can put the screw inside. So if have click, this is set for the strength we choose. In this case here, 0.45 Newton meter. And I'm using all the extension of the blade. So the blades came from here to here, sold by all the surface. So let's do the same with the titanium one. Just need to change this because the screw here is smaller, but the string will be the same. So let's do the same. Use all this area here. Set the torque. Squeeze the frame and also torque here. So as long both have the same force, to make it more scientific, we need to create another device to pull this blade with the same string. I don't have here, but just let's use the weight of this. Holding, but slips a little bit. Let's do the same here. Did not slip.